Welcome to day 38 of the bits video series. Today we are diving into how bits are stored in modern storage devices, specifically in hard disk drives and solid state drives. Let's explore how these devices use bits to keep our data safe and accessible. Before we get into the specifics, let's take a quick look at the two most common types of storage devices, hard disk drives HDDs and solid state drives SSDs. While both are used to store data, they do so in different ways. In this video, we will explore how bits are stored in each type of device and the advantages they bring to modern computing. Let's start with the hard disk drives or HDDs. These devices use magnetic storage to store your data. Inside an HDD, there are spinning patterns coated with a magnetic material. These platters rotate rapidly and the read-write head moves across the surface to either read or write data. Each tiny magnetic spot on the platter represents a bit, which can either be a 0 or 1 depending on the direction in which it is magnetized. Here's an illustration showing how data is stored in a HDD. The platters spin and the read-write head moves across them, reading and writing data by changing the magnetic orientation of the spots. These tiny spots made up of bits work together to store larger files, but at the core it's all just ones and zeros. Now let's move on to solid state drives or SSDs. Unlike HDDs, SSDs have no moving parts. Instead, they use flash memory to store data. In an SSD, each bit is stored in a floating gate transistor where the presence or absence of electrons determines whether the bit is a 0 or 1. The beauty of SSDs is its speed. They don't have to rely on moving parts, making them much faster and more durable than traditional hard drives. In an SSD, bits are stored in transistors that trap electrons. If an electron is trapped, it represents a 1. If it isn't, it represents a 0. Data in SSDs is organized into pages and blocks, making it quick to read or write. No spinning platters or moving parts, just pure electronic storage. So what's the difference between HDDs and SSDs? The primary distinction is the technology used to store data. HDDs relies on magnetic storage with moving parts, while SSDs use flash memory with no moving components. As a result, SSDs are faster, more durable, and wider than HDDs. However, HDDs are often cheaper and offer larger storage capacities for a lower price. To wrap things up, both HDDs and SSDs store our data as bits, but they do so in very different ways. Whether it's a magnetic storage in HDDs or the flash memory in SSDs, the ultimate goal is the same: to store our data effectively and reliably. The choice between HDDs and SSDs depends on our needs for speed, capacity, and cost. In our next session, day 39, we will explore bits in RAM, where speed is even more critical. Stay tuned to learn how bits are accessed and managed in random access memory, the powerhouse that helps your computer run efficiently. See you tomorrow.